Okay, so welcome. We're going to do an example of writing a function as a power series. So notice that we have this power series 1 over the 1 divided by the quantity 1 plus x cubed. Okay, now, before we get started, this looks like the the result of a convergent power series. Remember, for a power series, geometric series, we have n equals 1 to infinity of a times r to the n minus 1, right? And we know that this equals 1 over 1 minus r, right? Or excuse me, not 1, a. Okay, and this is for absolute value r less than 1. Okay, so this is what we know. Now, can we make this look like this? Okay, well, let's see what we can do. We can write this as 1 over 1 minus what? Negative x cubed. So why did I write it that way? Because I know that negative 1 cubed is negative 1. So that'll make that positive, and I go right back to where I started. So this is the same as this. So now, what does that give me? Well, then that tells me that r, in this case, if you will, r is equal to negative x cubed. Okay? So that's my r. Which means I want the absolute value of r to be less than 1. And I know that will be convergent. So that means that if the absolute value of is less than 1, then the power function will converge. Okay. So now, oh, by the way, just so you know, because we're looking at a power series, if we start this at 0, right, we would just write it this way. Okay, but again, it gives you the same result. Okay, so now, what does this mean? It means that this equal to this, which means that this, as long as this is less than 1, this can be represented as what? As a power series, and it's going to be of the same form as this. So A is 1, and then R is this, so it's going to be negative, keep doing that. So it'll be negative x to the third to the nth power. Okay, but again, the fact that this is negative cubed is still going to be negative 1, so we can write this as, equals equals 0 to infinity. So we can rewrite this as the summation of n equals 0 to infinity, and we can just take the negative 1 out of there, so it would be negative x cubed. And then we can use the power rule, so this would be to negative x to the 3n power. And so what does this equal? Well, that means that this is equal to what? This is going to be equal, well, when n is 0, this is going to be 1. So it's going to be negative 1. Oh, no, positive 1. Actually, let me rewrite this. This will be, just to see it better. This will be 3 to the nth power. There you go. Because I forgot, this will be a negative 1 to the nth power. So it's an alternating series. Okay, so if you wanted to write it that way, what you would actually do would be n equals 0 to infinity of negative 1 to the nth power times x to the 3n. Okay. And so when x equals 0, so what you end up getting is this. So when x equals 0, you get 1, and then you get minus, when n is 1, you get minus x to the 3rd plus x to the 6th minus x to the 9th plus, and so on. Now, what's the interval of convergence then? Okay, so we're not done. So here let's go back to this. Well, again, this is going to be the interval of convergence, and again, this is going to be the absolute value of 1 cubed, so this is just going to equal x cubed. And if you take the cube root of both sides, so again, what you're going to end up getting is x cubed is less than 1 and greater than negative 1. And then if you take the cube root of both sides, you get the same thing. So if you take the cube root of all 3 sides, you just get the same thing. So the interval of convergence is negative 1 to 1. Okay? And that's it. Have a great day.